VXLAN, which is one of the hot topic today, virtual extendable local area network. This is widely seen in data centers, even in service provider we see. Can also be adapted in various other places where a lot of virtualization, like VM machines, are seen. What is VXLAN? Virtual extendable LAN. This is one of the virtualization technology that solves the problem that we will face if we don't have enough number of VLANs. Classically, traditionally, we use VLANs to have multiple layer 2 broadcast domains. But we all know that the number of bits reserved for VLAN is 12 bit. So you can have only 4096 as the maximum number of VLANs. Cannot go beyond that. That limitation of 4096 is now broken because of this new feature called VXLAN. So as I said, in large scale data center, you will need more than 4000 VLANs. And also in a cloud environment, you need more network segmentation, more broadcast domain. So VLAN provides that. Sorry, VXLAN. That's what VXLAN is. It's an extendable LAN. The current LAN is only 4096. You can extend it more. How much more? Up to 16 million. Up to 16 million. Because 24-bit is given for VXLAN. Now, what is the importance of VXLAN? Why it is so important? Number one, the purpose. There are various reasons why we need VXLAN. One is purpose, the other one is encapsulation, overlay network, scalability, multicast broadcast, integration, etc. We are going to see, but let's see one by one the purpose of VXLAN or why VXLAN. As I said, in a virtualized environment, we need a layer 2 communication. We don't want routing. We want layer 2 communication. We want layer 2 infrastructure rather than layer 3 infrastructure. So what we can do is we can have an overlay. We can have an overlay on top of the physical underlay infrastructure, and this overlay will be layer 2 tunnels. So you don't have that layer 3 I can say boundaries. What do I mean by boundaries? See, when we have layer 3 routers, and when you send a packet from A to B, for every hop there will be a decapsulation and encapsulation. For every hop there will be a decapsulation and encapsulation. For every hop there will be a change in source and destination MAC address, which is not acceptable in a virtualization environment. So we need a tunnel between these endpoints, and we can pass the traffic like this, so that The destination MAC address that is given by A will be the MAC address of B, not the MAC address of the router here. So we need layer 2 tunnels, and we need in large numbers. Even though we have a lot of layer 2 MPLS VPN stories, they are more complicated. Yes, Girish, you have some question. Yeah, it's coming later. It's coming later in detail. Here we are trying to understand the purpose of this VXLAN. We can have a tunnel, or we can have a virtual topology, a logical topology, a overlay. That's what here it means. Network overlay. A network overlay. A virtual topology over the physical topology. That overlay, the virtual topology is the tunnel. Every tunnel technology, not only VXLAN, take any tunneling concepts, you will see encapsulation. Something will encapsulate something so that the traffic can be pushed, moved. So here, what is encapsulating what? In VXLAN, the layer 2 is encapsulated with layer 4 UDP packets, and the packets are routed using the upper layer, layer 3 header. What do I mean by this? Now this will explain the tunnel, what tunnel means. You see, we have a packet here, we have a computer here, and we have another computer here, and they want to communicate. And what is needed for this communication is not layer 3, we want layer 2 communication. But unfortunately, you have layer 3 network in between. We have a layer 3 network in between. But this computer is in 10.0.0.1 and this is in 10.0.0.2. You want these two to communicate, but how is that possible when you have routers in between? I have router 1, router 2, router 3. Let's say here you got some networks like 172.16.01.02/24, 172.16.1.1/24, 1.2. So if A and B needs to communicate, you need a switch in between. In another word, you need a layer 2 connection in between. What we do is we create a tunnel. Now, this tunnel is having this router's address as the source, if you see in this direction from left to right, and this router's address, IP address, as the tunnel destination. Say, for example, 1.1.1.1, 2. So this address is 1.1.1.1 and 2.2.2.2, using which the tunnel is negotiated. We call it as VTAP address, virtual tunnel endpoint address. VTAP address, virtual tunnel endpoint address. Now, what is this tunnel going to do? This tunnel is going to carry layer 2 traffic. But I told you, tunnel is nothing but encapsulation. And if you need to carry layer 2 traffic, then the tunnel needs to have A layer 3 address to move the packet from R1 to R3. At the same time, the layer 2 has to be preserved. So what happens is, here from A, you have 7 layers, and you got the data link layer here. This PCA is generating this packet. And there is a layer 3 header with A as the source and B as the destination. Even the MAC address is also A MAC address and destination MAC address is B. When it hits the ingress router, which is ingress router here, this tunnel endpoint router, which is R1. What R1 does is it encapsulates. It encapsulates additional layer 4 here. Please understand, you already have a layer 4 here, a layer 3 here, layer 2 here. Now, without disturbing this ingress router gets some overhead, means more pain. R1 takes more pain. What pain it takes? It encapsulates additional layer 4, layer 3, layer 2 header, layer 1 header. Now, what do you have in layer 4? You have this UDP port number that is given for VXLAN, so that every router in the middle will understand this is a VXLAN packet. Do anyone know the UDP port number of VXLAN? Yeah, we saw in the previous classes. 4789. 4789. So this port number, with this port destination port number, a layer 2 header is added, and layer 3 IP address will be 1.1.1.1 and 2.2.2.2, because that is the tunnel source and tunnel destination. But the original IP address is 10.0.0.1 here and 10.0.0.2. Those things are not disturbed. Likewise, the MAC address in the destination layer, the data link layer also preserved. The original MAC address, AB's MAC address is preserved. So you got additional different layer 2, where now the MAC address is this egress address MAC address, let's say EEE and FFF. That becomes the MAC address. And now the packet moves from here to here, and then again decapsulates. Only this layer 2 will change, and packet moves here. At last it reaches the final destination 2222, which is the destination address in this upper layer. So the packets are moving from R1 to R3 by using the upper layer only, the newly added layer. Once it reaches the final destination, that newly added layer will get removed. And now the egress router can see the original destination, which is B. So by looking into the ARP table here, it understands B is in this direction. It delivers the packet here. This is what tunnel means. This is the type of encapsulation that is done to your frame so that the original layer 2 address will be preserved, which is very important for virtualization, which is very important for data center where a lot of virtualization VMs are present. So here we have seen VXLAN purposes it preserves the original layer 2 ether frame by encapsulating additional layer 4, layer 3, layer 2 headers. The additional header, the top layer, is what used for moving the packet between the tunnel endpoints called routed underlay. Once it crosses the routed underlay and reaches the egress router, the original frame will be seen and the packet can be now delivered to the layer to destination. So the encapsulation, the additional header, is what transports the Ethernet frame, the layer 2 frame, across the IP header. The original Ethernet frame is preserved. Do you have any question? As I said, VXLAN is an overlay network. It's a virtualized overlay network on top of the physical network. So this overlay network, you can segment into multiple overlay tunnels, multiple logical topology. How many? 16 million. 16 million segmentation, virtual segmentation you can create on top of the physical topology. One physical topology, 16 million logical topologies. As I say, there are 24-bit. It is not 12-bit. VLAN is 12-bit. VLAN is 12-bit. Because it is 24-bit, this is more scalable. For a large-scale environment like cloud or large data center, this is really needed because they need more segmentation, layer 2 segmentation. Again, why VXLAN? Because you have VXLAN, you can avoid broadcast. Multicast, unknown unicast, and broadcast are now sent only through those tunnels, not throughout the entire physical topology. It is only flooded inside the tunnel, the logical segment, logical topology. So VXLAN uses multicast to handle broadcast. So if you have a broadcast to be sent to everyone, it will not be sent to the whole physical domain, physical data, physical network, physical topology. It will be sent to everyone in that VXLAN tunnel by using multicast. So whenever destination is unknown, you call it as unknown unicast traffic. Whenever you want to send a copy of a traffic to multiple destination, we call this multicast traffic. All these are handled by multicast. So no broadcast. And it is using multicast in order to support layer 2 broadcast domain in a layer 3 network. Usually, layer 3 networks will never allow layer 2 broadcast to pass through, isn't it? Layer 3 routers will never allow layer 2 broadcast. Not possible, right? It's not possible. router will stop the broadcast because every port on a router has got a broadcast domain. But once you form a tunnel, you may have many routers in the middle. When a broadcast enters on the increased router, it goes to the other end without any problem. If you don't have this VXLAN tunnel, when a broadcast comes here, that's all, it stops here. We don't allow. So VXLAN supports layer 2 broadcast domain in the layer 3 network, which is needed for virtualization environment. Like I was drawing when I was explaining this page. 10.0.0.1 wants to talk to 10.0.0.2 on the other side. And let's say they are VMs, or they are all in same network. In the middle, you got routers. So to learn MAC address, they send ARP layer 2 broadcast, but the routers won't allow. When you extend the using tunnels, the broadcast is allowed. Any question on this page? So we have seen why VXLAN means the purpose and what it does, what advantage we get through encapsulation, through overlay network, how the scalability is improved to meet the current cloud technologies, virtualization technologies, how this multicast solves the problem of allowing a layer 2 broadcast over layer 3 network, and so on. Again, why VXLAN? The integration. The virtualization that we do using VXLAN, the virtual tunnels that you create using VXLAN, that makes all the software defined technologies, concepts, to take the privilege of, to leverage the benefits of VXLAN. What do I mean by that? Because VXLAN reduces the complexity by simplifying layer 2, layer 3 communication over a physical network. You can have a layer 2, layer 3 communication using the overlay network. I repeat, physical network has got a lot of limitation. When you are able to create virtual tunnels, you can have your own topology because it's virtual. And now, for on top of this virtual topology, you can easily do the software-defined solutions than doing it on the physical network. Physical network has got a lot of problem. Physical network has got a lot of limitations. To overcome those limitations, we do a lot of protocol after protocol after protocol, and then we try to have software-defined networking, which is very complicated for software-defined networking to function. Now you have a tunnel, just simplified tunnel, that user-defined tunnel, which can be easily customized. The customization is not that easy in the physical network. So that physical network is now an abstract. Physical network limitations are now hidden from the site. Physical network limitations are no more a barrier. Now you need to focus only the tunnel and design that software definition, software defined applications. You need to now create a software to manage and to maintain this overlay tunnel, not the physical underlay. So this is making it easier to manage and provision virtual networks. So providing virtual networks and to manage virtual networks using software defined solution is easier if you do on VXLAN tunnels rather than doing it on the physical network. So what do we see here? It allows for the abstraction of underlying physical network, VXLAN. VXLAN hides, abstracts the underlying physical network, which has got a lot of limitations, in which software-defined solution becomes tougher. So because it is abstracted now, because you got the virtual tunnel, not the physical connections, it is easier now for the software-defined uh, network developers to develop a tool to manage and provision virtual networks. Okay, use case, where do we use VXLAN? A large data center or any data center is full of VMs, virtualization. So we definitely see VXLAN on data center environment. And wherever you need multiple tenants, multiple multiple network isolation, multiple tenants. That is what network isolation. One customer traffic is isolated from the other customer traffic, though they are all using the same data center or service provider. Isolation. Just to make you make understand, I want to use this like you have multiple banks as your customer. Multiple banks are your customer. Each bank is a tenant. And now to isolate the traffic of one bank from the other bank, we can provide them different VXLAN tunnels. But the underlying physical network is same for all the banks. You got a large pool of resource as a physical topology, and you create a segment called VXLAN tunnel for each customer, each bank. Though they're all going to use the same physical network, their communications, their networks, their distribution of routes, everything is totally isolated by creating multiple VLANs. We can have up to 16 million VXLANs by creating multiple VXLANs. Sorry, not VLANs. Earlier is VLANs. VXLANs. So you can have a scalable network segmentation. Many network segmentation, many, that's what scalable, as many you want. It is also used in cloud computing, not only the data center and cloud computing environment to support virtual machines, virtual machine VM mobility, and dynamic network provisioning. Like VM mobility is nothing but a virtual PC moving from one location to another location seamlessly. They they get attached to the network because of VXLAN. So there is seamless locomotion, movement. So the moving device won't feel that we are getting, means seamlessly it moves. There is no drop in the connection, seamlessly it moves because VXLAN uses multicasting to support this seamless mobility. And network provisioning, as we discussed in the integration SDN, uh, network provisioning is easier because you have software developed to provision dynamically. So VXLAN is a powerful technology that enhances network scalability, flexibility, making it popular choice for the modern data center and cloud computing architecture. What we have seen so far is what is VXLAN. Now, how we will define VXLAN? VXLAN is the encapsulation of layer 2 with layer 4 UDP and move the packet using the IP to the other end and decapsulate the UDP header so that the original destination MAC address is visible for the egress router to push it to the final layer 2 domain. And we also saw the advantages of doing that. More repeated word is virtualization, VM, isn't it? Cloud networking, data center. So there is a limitation in VLAN. You don't have that limitation now because of VXLAN can support up to 16 million using the 24-bit, whereas VLAN is only 12-bit 4096 segments. And the other big advantage is because it is going to abstract from the physical layer, the physical topology. VXLAN is an abstract. It abstracts the physical topology. Providing a software-defined solution is made easier now. It's no more complicated. Now, VXLAN alone is not that effective. VXLAN plus EVPN will be more effective. What is this EVPN? It is Ethernet VPN, Ethernet Virtual Private Network. What it is, it's one of the BGP support. BGP's feature helps to replicate the MAC and IP information from one tunnel endpoint to other tunnel endpoints. You may have multiple tunnel endpoints. So this avoids unnecessary flooding of MAC IP information throughout the VXLAN domain. In short, VXLAN EVPN is control plane oriented VXLAN. Simply VXLAN is data plane. VXLAN with EVPN is control plane. EVPN provides that control plane. VXLAN EVPN, Ethernet Virtual Private Network, combines the VXLAN encapsulation, which we just saw, with the EVPN control plane to provide more scalability and more efficient network virtualization solution. We just saw VXLAN encapsulation. Now we are going to additionally add EVPN control plane to it so that we can avoid broadcast. As a result, scalability is improved. It becomes more efficient virtualization network solution. So VXLAN along with EVPN is used in data center, large scale enterprises environment also. So just with VXLAN, we have some limitations because of uh, flooding that can be solved by using this EVPN. So let us have a deep look into the VXLAN EVPN now. You know what is VXLAN? The first paragraph, it uses 24-bit, and the 24-bit identifier is called network virtual network identifier (VNI). Sorry, correct. VXLAN, like we have VLAN ID here, we have VNIs, virtual network identifiers. And we also saw VXLAN uses UDP encapsulation, all those things. Now let's come down to this second point, EVPN. EVPN acts as a control plane. As I said earlier, it is one of the BGP feature. Now what is this EVPN BGP does? It distributes the Ethernet VPN information. What do I mean by Ethernet VPN information? The IP and MAC address information that is connected to the VXLAN. See, EVPN provides advanced features such as MAC learning, MAC address learning. The reachability information is nothing but the VTAP address, IP address. For this MAC address, I have which VTAP I have to go, to which tunnel endpoint I have to go. What is the IP address of the tunnel endpoint? No, that's what reachability information. So this EVPN distributes these informations. Whenever a new MAC address is learned on one of the VTAP, one of the tunnel endpoint, BGP immediately distributes the information saying this MAC address is available in this tunnel endpoint to all other tunnel endpoints. So whenever you have multiple tenants, it's really important. Reduces traffic. All right. So high availability scenario. So whenever there's a change in the MAC address learning, immediately what will happen? An update will be sent. Seamless vMotion can be done like that. Please ask question if you have here. No, the host is moving from one location to another location. Now, a VM is moving from one location to another location. Earlier it was in, earlier it was, yeah, yes. Earlier it was in VTAP 1 and now it is going to VTAP 5. So immediately the control plane will say that the VTAP address for this source is changed. Earlier it was 1.1.1.1, now it is 5.5.5. So there is an immediate update sent using this BGP about the reachability information. So this is how the high availability is seen. The benefits of VXLAN EVPN. First point, enhanced scalability. So when the MAC address is learned on the ingress tunnel VTAP, that gets immediately distributed. And this happens for every single segment individually. Optimized MAC learning. In traditional VXLAN deployment, MAC learning can be less efficient and lead to increase of broadcast traffic. Because there is no controller, there is no control plane, it needs to flood it. If no EVPN, always need to flood. Whenever new MAC address is learned, that information is flooded so that other VTAPs can learn. But after the EVPN, it is BGP one going to distribute the MAC address information across the network by reducing the flooding, and as a result, it improves the efficiency. And it is also a control plane for both layer 2 and layer 3 service. What is layer 3 service? If you want to communicate between different VXLAN, hello, if you want to communicate between the members of two different VXLAN, we call it as layer 3 service. Not only that, if a member of a VXLAN communicates to the internet, that is also layer 3 service. For this, you need a very good control plane to direct the traffic towards the destination. EVPN can do this. So that's what we call it as an integrated control plane. Not only for layer 2 communication, even for layer 3 communication, this EVPN is good. EVPN integrates with VXLAN to provide unified control plane for both layer 2 and layer 3 services. This integration simplifies the network operation and reduces the complexity involved in managing large-scale virtual network. Like if you want to do without EVPN, you need to have a lot of additional configurations to achieve it, which is solved here just by enabling this protocol. Yes. Okay, I'll make it simple. Forget about all these big technologies. Now you see, we know inter-VLAN routing. Do you remember inter-VLAN routing? When we did inter-VLAN routing, we did two methods. One is router on a stick. You remember router on a stick? Please respond, yes or no. Do you remember router on a stick, anyone? Okay, someone explain what is router on a stick to the. Yeah, correct. That's what. This is what we called as router on a stick. So you have one sub-interface for VLAN 10, what our Arun explained, another one for VLAN 20. So now traffic goes from here to layer 2 switch and then goes to router and get router, come out as layer 2 traffic and talks here. So you see, because the switch don't have a control plane to communicate in between these two different VLAN members because the switch don't have a control plane to control the traffic, to direct the traffic. Even though this PC is connected to the same switch, the switch don't know. The switch don't have a control plane. So we need an additional external router to do this. And now this is two separate entity. It is not integrated. So later what we did is we had a multi-layer switch. We replaced the switch with a multi-layer switch, which is an integrated box. As a result, a single processing is enough for you to decide whether it is locally switched to the same VLAN member or to get routed. Single motherboard. Now you got the control plane placed inside the data plane. That reduces the complexity. Same story here. VXLAN without EVPN is you don't have a routing capability. It's a simple layer 2 switch. VXLAN without EVPN. When you have EVPN, you also get routing capability. That's what here I can compare to make you understand this. Is this clear? Integrated control plane for both layer 2 and layer 3. When a multi-layer switch can do forwarding decision, layer 2 decision, and layer 3 forwarding decision, EVPN can also now do forwarding between different VXLAN member as well as within the same VXLAN member. Is it clear? You asked me for an example. I have explained one example. Is this clear now? Okay. Now, multi-homing, you know what is multi-homing? Multi-tenants. You will have multiple connections so that if one connection goes down, you will have another. Let's read what is written here. EVPN provides built-in mechanism for multi-homing and redundancy. This means that you can connect single VXLAN segment to multiple devices for redundancy. So that if one VXLAN device fails, you will have another VXLAN device. So you got multiple upstream for high availability. Because basically they all belong to same VXLAN. Only the device is different. Initially you connected to leaf 1 and when link failed then you lose connection. But when you take one connection to leaf 1, another connection to leaf 2, you have no problem. Even if one connection goes down, you can still go via leaf 2. You can also have load sharing. MAC address mobility. I think we saw this earlier. EVPN handles MAC address mobility more gracefully, which is critical for virtualized environment, where the virtual machine more frequently moves between different physical hosts. That's called vMotion. When a VM moves from one host to another host. The identity also moves from one physical host to another physical host. Earlier, the identity was connected to leaf 1. Now, when you move that VM to another physical host, which is connected to the 10th host, which is connected to the 10th host is connected to 10th leaf. Now, the identity now moves to 10th leaf. So, EVPN immediately distributes this info, saying earlier this destination was in leaf 1. Now it is in leaf 10. MAC mobility. Do you understand this MAC address mobility? Or do you want me to explain? Let's see. Though I'm not a VMware guy, I know a little bit of how it works from the Cisco perspective. Let's say you have a server. It can be a Cisco UCS server or Dell server, whatever. But you got a lot of VMs. This is connected to leaf 1, where the tunnel starts. That's the tunnel endpoint. So likewise, you have many leaves. All are connected to spines. Now, to all these leaves, there are some physical servers with a lot of VMs in it. Now, what happened is the user who was logged in here is shifting his location to here. He signed off from here. When he was here, EVPN said this particular guy with this IP address and MAC address, let's say AA, is in leaf 1. So everyone knows that if I need to go to AA, I need to go to leaf 1. Right? Everyone knows that they need to go to leaf 1. But now he switches off, he sign out from here, and he logs in with his credential here. When he logs in with a credential here, all the policies that were binded for the user is now shifted to the VM in this host, physical host, including MAC address, if it is Cisco UCS server. Because from the MAC pool, the MAC address will be taken. The MAC address which was binded to this user here now shifts to here. IP address, MAC address, and all policies moves here. Everything moves to this VM. It's VM only now. Just plug the server profile. Take the server profile from there and give it to here. That's all. So exactly the same server now boots here. That's called vMotion. According to the Cisco guy like me, this is what vMotion. There may be more to it, but I'm not aware of all this additional stuff. Now, when this guy boots here, EVPN immediately alerts everyone, hey, AA is no more in VCAP 1. It's no more in leaf 1. It is in leaf 5. Is this clear? MAC address mobility. Yeah, wherever you move, the policy follows. If policy allowed you, yes. If your UCS server policy allows, yes. This is VXLAN. Whoever comes there, the EVPN is going to distribute. Moving between tenants is not your VXLAN, it is your server policy, your UCS. If that allows, yes. Okay, next, support for layer 3 services. In addition to layer 2 VXLAN services, EVPN supports layer 3 VXLAN service, which means you can communicate, you can use the same EVPN infrastructure to support both layer 2 and layer 3 VPN. Right? We already saw like integrated, the word integrated. Layer 3 services, as I said, within the VXLAN or between different VXLAN or between the VXLAN member to the internet. These are all layer 3 services. I have a separate topic for VXLAN services coming next. Next is efficient broadcast handling. See, because you have EVPN for all broadcast, multicast, and non-unicast, you don't need to flood all the time because BGP is the one which is going to carry the traffic. When there is no EVPN, there was unnecessary flooding. Now that unnecessary flooding is reduced. So this improves the VXLAN network performance now. We are just trying to understand the importance of EVPN. We have seen 7 points. Benefits of EVPN with VXLAN. Enhanced scaling, optimized MAC learning, integrated control plane, multi-homing and redundancy, MAC address mobility, support for layer 3 services, efficient bandwidth area. Now use case, as you already know, it is used in data center, service provider, cloud environment, right? So VXLAN combined with, EVPN combined with VXLAN has got a lot of benefits like scalability, efficient design, flexible design, mobility, which is needed in all modern virtualized network. As I told you, we have a separate topic here now to explain what is that layer 3 services the VXLAN can support. VXLAN primarily focuses on layer 2 by encapsulating. We learned that. However, it also extends the support to layer 3 services in some additional integration. Number 1, VXLAN to VXLAN routing. So VXLAN routers can route traffic between VXLAN segments. For example, if you have multiple VXLAN segments, which is attached to different VNIs, means different VXLAN network identifier, it's like 2 different VLAN. That's why I took the example inter-VLAN routing. This is like inter-VXLAN routing. If you have multiple VXLAN segments, each associated with different VNIs, VXLAN routers can handle routing between these segments by enabling layer 3 connectivity within the VXLAN overlay. So layer 3 routing is supported. Between VXLAN, layer 3 communication is possible. You no need to have an additional routing device. Next one is VXLAN to external routing. Hope you understand from the title itself. VXLAN router can also connect the VXLAN segment to the external L3 network, such as internet or other enterprises. Usually, all the enterprises are connected to data center. So now data center, which is running VXLAN, need to extend that to the enterprises, which is possible. This integration allows the communication between the VXLAN segment and the external IP network. Right? Any question on? Sure. Any question on layer 3 service? Two things only you learn here. Routing between VXLAN, routing between a VXLAN and internet or enterprises. Yes, and how. Next is EVPN integration, which uses BGP. EVPN uses BGP to distribute both the MAC address and IP address route information across the VLAN network, VXLAN network. So this allows the efficient layer 3 routing within the VXLAN overlay. Is this clear? Very simple. It is supporting the previous page. How is layer 3 VXLAN? How is layer 3 routing within the VXLAN overlay supported? Because you got BGP. BGP is advertising both MAC and IP address. Because it also have got IP address, though it is a different network, still it has got the information and routing is possible. It has got the information, what information? IP to MAC. IP to MAC and VTAP, to which VTAP they are connected. So routing is possible in the VXLAN overlay. Not only that, you know what is VRF? For every separate VRF, for every separate layer 3 routing domain, you can have now VXLAN. IPVRF. EVPN supports the concept of IPVRF, which enables the creation of multiple VRF or virtual routing table. This allows the separation of layer 3 routing domain within the same VXLAN. So can we have VRF in VXLAN? Yes. Next answer is we have for the question. Can we have VRF inside VXLAN? Yes, you can have. If you see all these things, then ACI is very easy. ACI, they will say tenant. Under tenant, you will have VRF. What it is? Tenant is one VXLAN. Then inside that, you can have VRF. And you can also have routing between the layer 3 domain in the same VXLAN overlay. So all this put together is what ACI with an automated tool. Integrating layer 3 and layer 2 services. VXLAN can integrate layer 2 and layer 3 services, allowing single VXLAN infrastructure to handle both layer 2 and layer 3. With EVPN, you can use single VXLAN infrastructure to offer both layer 2 bridging as well as routing VPN services. To explain this only, I took the layer 3 routed multi-layer switch, and the router elastic example. Routing within a VXLAN. Inside the VXLAN overlay network, routers can perform layer 3 routing based on the IP address, which is distributed by EVPN. This provides a seamless connectivity between the different VXLAN segment and the external network as well. This is discussed earlier. VXLAN handle multicast and broadcast within the overlay network. So this helps in a scenario where layer 3 service need to handle broadcast and multicast. So if you have a layer 3 infrastructure where broadcast is done, multicast is done, can VXLAN support? Yes, VXLAN even can handle that. Next, multicast support. See, you don't need to rely on the multicast protocol like PIM, etc. VXLAN by itself can do multicast. VXLAN can use multicast for distribution of broadcast and multicast traffic across the overlay network, which is essential for layer 3 services. But it does, without relying the multicast protocol. That is important. It is coming in some other place. Okay, we call it as head-end replication. It's the next topic. Head-end replication. Head-end replication don't rely on the traditional multicasting routing protocol. Here, this relies on multicasting routing protocol. If you don't want to rely on it, then you need to enable head-end replication to replicate this broadcast and multicast. That is coming next. Oh, here it is. Head-end replication. I'm very sorry. Here itself it is mentioned, but in detail it is coming later. Head-end replication is one of the method. It is supported in some ASR devices. Not on all ASR devices. Head-end replication. Some VXLAN implementation uses head-end replication for multicast traffic, where the ingress VTAP replicates the multicast packet to multiple egress VTAP, reducing the reliance on multicast infrastructure. So it won't depend on, it won't rely on the traditional multicast infrastructure. No need of that. You don't need a multicast routing protocol. Reducing the reliance on multicast infrastructure in the underlying. Oh, here comes the topic in detail. Head-end replication. What is head-end replication? It's a method for distributing multicast traffic across VXLAN overlay. Listen, instead of relying on the traditional multicast routing protocol like PIN to manage the multicast traffic across the entire network, head-end replication centralizes this function at the point where the multicast traffic enters the VXLAN overlay. So as the multicast traffic enters, it immediately delivers a copy of it to all the other remote tunnel endpoints. That's simple. That is why it is called as head-end replication. What is a head-end? Who is a head-end? Ingress router is a head-end. Head-end, tail-end. When a multicast traffic enters the head, means the VTAP, ingress VTAP, immediately it replicates, it takes a copy of the packet and replicates to all the remote VTAPs. It's supposed to get the packet. Not to all VTAPs, whichever is supposed to get, whichever is enrolled to same VNI gets a copy. And there is no need for a multicast routing protocol. This. For head-end replication, there is no need for multicast routing protocol. See, these are the steps. Ingress VTAP. The multicast traffic is entering. And now the ingress VTAP encapsulates traffic replication. So instead of relying on the multicast routing to propagate this traffic, instead of the ingress VTAP performs the replication of multicast packet. How? Ingress packet creates a multiple copies of multicast traffic, one for each egress VTAP, and it sends to the tunnel. Now that encapsulation happens on the ingress router for each copy, and the copy reaches the appropriate egress router where it gets decapsulated, and then based on the IP, the packet gets delivered to the destination. So what that egress VTAP does, upon receiving that encapsulated packet, it decapsulates it and forwards the packet to the original multicast destination based on the original multicast address. So what I'm trying to say here is inside the VXLAN, there is no need for dependency on multicast routing protocol. VXLAN itself can replicate it. It's called head-end replication. So benefits, the multicast complexity is avoided. To carry multicast, you don't need to have another multicast routing protocol. Avoids the need of multicast routing protocol within the overlay network. That's the biggest advantage, benefit. Simplifies as the network designed by head-end replication. Avoids complexity of multicast routing, same story, okay, only different title. So of course the scalability will increase. You don't need to depend on the traditional multicast routing. Use case, wherever you have a lot of broadcast and multicast traffic, you use head-end replication, especially on data center environment. All right. So that brings us to the end of. And we have seen VXLAN. We have seen VXLAN with control plane EVPN. We have seen the benefits. We have seen layer 3 services. We have seen head-end replication. Now let us see the configuration steps. Here is the document. I'll share this document to you. Initial network configuration, provide IP address, VTAP address, everything. Put some routing protocol so that all that channel endpoints can ping each other. All right, that is what configuring underlay network. Enable IP address, enable routing protocol. And then configuring the overlay network, which is the tunnel. All right, so define the VXLAN network identifier VNI. Right, so how do you configure tunnel endpoint? You need to define the VNI number, isn't it? And then for the VTAP, there should be a number. For every tunnel endpoint, there should be a number. And here, what do you see? This is the VNI. Sorry, VTAP. VTAP interface. This is VNI. NVE is a network virtualization edge. It's the tunnel interface, and this is the VXLAN ID. This is the VNI, the VXLAN ID, and now the VTAP address is the address on the loopback interface. And now we are using EVPN, so BGP is the protocol to replicate. Any traffic that is coming inside creating VXLAN interface, okay. Interface VXLAN 1, VXLAN ID, given number, and then bridge group VXLAN 1. This is the syntax. Again, this may configuration steps may be slightly different for Nexus. This is for iOS XR. Configuring EVPN control plane, enable EVPN routing protocol. You need to go under BGP to do that. And then enable EVPN by going under address family, L2 VPN, EVPN, and then form a neighbor with the remote VNI. All right, and then EVPN uses different routing types to distribute MAC address, IP prefix, and other information. Type 1, Ethernet auto discovery. Type 2, MAC IP advertisement. Type 3, IP prefix advertisement. So here we see that under EVPN we go and say advertise L2 VPN EVPN. Configuring layer to layer 3 connectivity. layer 2 bridging, we say bridge domain, and then we call the VNI that we mentioned in the beginning. Yeah, 1001 is what we assigned it to the tunnel interface, and that we are having under the bridge domain. And for layer 3 routing, we need to provide an IP address for each VLAN that can be used for routing. And then verification command and troubleshooting. Now, this will not give you the complete knowledge of configuration. You need a nice lab guide, which I'll be sending later. This is just for you to know the steps, what all involved in having VXLAN in here. Right?